So I think you are able to see on the screen. This is the course curriculum that you are having. Okay. So this is actual the syllabus that you are going to have under biomedical instrumentation. Okay. So in this particular syllabus, we are majorly going to concentrate on these topics. Okay. The design and biomedical transducers. Okay. That means you are going to learn about the EEG, EMG, and then you are going to learn about the blood pressure, and then health monitoring systems, all those things. Okay, you may go, you may also go through the transducers, sensors, which are used for measuring the physical measurements, and then and then you may go through amplifiers, all these things. You may go to different things. So you may cover the electronics, and along with you are going to apply the electronics in medical. Okay, you are going to apply this electronic in medical applications. Okay, so you and the next thing, you may also go to the pulse oximeter, defibrillators, and then pacemakers, all these things. Okay, so the biomedical instrumentation, you are going to cover all the instruments that you are going to have. Okay, but you are not going to cover the imaging techniques like the X-ray, ultrasound, MRI, all these things in this course, because you are going to have another course in your second semester, that is medical imaging. So in that particular medical imaging, you may go through the different uh, imaging modalities like X-ray, ultrasound, MRI, all these things. Okay, so the course will be very easy, and and then coming on to the exams that you are going to have, you will have 60 marks. Okay, you will have the 60 marks end semester examination. Okay, that means in the end semester examination, your end semester exam will be conducted for 60 marks. So the remaining 40 marks, that the total course will be for 100 marks, right? That means you are going to get 4 credits. Okay, so in these 100 marks, the 60 marks will be for end semester examination, and among the remaining 40, 20 marks will be for your mid semester examination. Okay, so at present, normally you may have the mid semester examinations in August or September, but because of the COVID-19 pandemic, so you are not going to have any mid semester examination, but you may get quizzes and assignments yeah, in between 2 to 3 weeks. But every 2 to 3 weeks, I think you may have gone to the academic calendar. So if you gone to the academic calendar, you can see in between the academic calendar that you may have the quiz one or assignment one, quiz two, or assignment two, like that. Okay. So we are going to provide you the quiz. You have to attempt the quiz, and depending upon your marks that you had obtained during the quiz, so your 20 marks will be allotted. Okay, so the semester exam marks will be allotted depending upon your quizzes and assignments. Okay, and the remaining 20 marks. Okay, so you are having another remaining 20 marks. Okay, this will be your teacher assessment. Okay, that means this number will be given by me. So I am going to divide these 20 marks into 10 marks for attendance and 5 marks for assignments, and another 5 marks will be for some other work. Okay, so I will make you know that what will be the 5 marks will be given. Okay, so the overall 60 will be for end semester, and among the 40, 20 will be for mid semester, and remaining 20 will be your teacher assessment. Okay, and in this teacher assessment, it will be given depending on 10 marks for your attendance, 5 marks for your assignment, and remaining 5 marks I will let you know. It will be some small project, or I will make you know after having the to a few classes. Okay, so in this way your complete course is going to be divided. Okay, so you have to do the for complete 100 marks, but the end semester will be 60, and mid semester will be 20, and remaining 20 will be teacher assessment. Okay, so 1 minute. So I think you have understood the pattern. This will be same for all the subjects. Okay, in all the subjects you are going to have the same. You are going to have the 60 marks for your end semester, and 20 marks will be your mid semester, and 20 marks will be your teacher assessment. And the teacher assessment will depend upon the faculty how they are going to divide this teacher assessment. Okay, so this particular biomedical instrumentation course will be for 4 credits. Okay, among these 4 credits, you are going to have this will be compare lecture. There will be no any tutorials or practicals. You are going to have only lecture classes in this biomedical instrumentation. Okay. So it will be for 4 credits, and I already explained you how the marks are going to be divided. Okay. So the classes will be conducted in MS Teams. Okay, because as the classes are going to be conducted in online mode, so you will be having classes in MS Teams itself. Okay. So I will make as I had first make a team. So I am going to post the meeting details in the team as I had posted previously, right? So you just have to click on the meeting details, or if you are not able to find the meeting details, you may get the meeting details in your calendar also. If you go to the calendar, so in the calendar also you can get your meeting details. So you have to join the class, and then we will have the class here. Okay. So no, there is no worry about how you are going. I will share each and every PPT with you. Okay. Whatever PPT I am going to explain you in the class. Okay. Like I am going to explain you this PPT. So after the completion of this PPT, okay, once one particular PPT gets completed, so I will share this PPT to you via mail. Okay, you will get the PPT in mail, and you may also access this in the modules. I think you have modules or not. So otherwise, I will also upload the PPT in MS Teams also. So in the same team, the team which is named with biomedical instrumentation. So I will also upload the PPT in the Teams also, so that if you are not able to get it in the mail, you can get it in MS Teams. Okay, so this is about the your syllabus. So majorly we are going to cover the instruments that we are going to use. You are going to cover the pulse oximeter. You may going to cover the EEG, EMG, ECG, and then you are going to cover the blood pressure, and then you may also have the lab in the next semester. Okay, you are going to have a biomedical engineering lab. So in that lab, you are going to do these things in your lab. Okay, in the lab also you are going to have the ECG machine. We have the EEG machine, EMG machine. So whatever you are going to learn in this subject, biomedical instrumentation for the first semester, you may have everything in lab. Okay, in the second semester, whenever you are going to take your lab course, so in the lab you are going to go through all these devices. Okay, I will explain you, and if possible, I will also show these instruments to you. Okay, at present I am taking from home. If I usually I used to go to my lab also, biomedical lab. So if I go to lab, then I will also show you the devices, and you will also do these devices in second semester when you are going to have the biomedical engineering lab. Okay, so uh, this is don't worry about the subject; it will be very easy. And okay, so whatever I am going to teach you, whatever I am going to explain you here in the class, so I will majorly cover all the topics from these PPTs only. Whatever PPTs if I'm going to share or what I'm going to take in the class, so I will cover the exam paper from this syllabus only. Okay, so try to attend the classes and try to go to the PPTs, all these things, and then you may get the marks easily. Okay, so it is not a difficult subject. So remember the code for this. The code will be AM2134. The code is not that much important. So but remember the subject's name, biomedical instrumentation. Okay, so let us go through brief introduction about biomedical instrumentation. So normally you people know that what is instrumentation, right? Instrumentation is the use of measuring instruments, right? What we are going to do in the instrumentation, normally in instrumentation, we are going to use the measuring instruments to monitor and control a process, right? If we are having any particular process in your industry or anything. So what happens in your industry, if you are going, if you want to monitor or if you want to measure something, what you will use the instruments, right? So using the instruments for measuring some, that means measuring some parameter or controlling some parameters is known as instrumentation. Okay, okay, using some instruments to measure or control some monitor or control some process in the industry or anything, not only industry, each and every application. If you want to monitor something or if you want to control something, the first thing you need to do is you need to measure the parameter, right? Which parameter you want to control or the which parameter you want to monitor. So there you will use instruments for measuring that parameter, right? So the use of these instruments is known as instrumentation. Okay. So this, I think this definition you people know it. And okay, and then coming on to the biomedical instrumentation. Okay. If you are creating such an instrument which will be useful to measure, record, and transmit data to and from the body. Okay, like normal instruments, you will use the instruments for measuring the parameters, right? You may measure the temperature. The temperature is a parameter for you, or you may measure air pressure, or you may measure something else, right? You may measure the heat, you may measure humidity, or you may measure many things, right? So, but what is biomedical instrumentation? The biomedical instrument is a specific field in instrumentation where you are going to measure, record, or transmit data. Okay, you are going to measure some physic parameter from your body, like you are going to measure the EEG wave, or you are going to measure the EMG wave that is going to happen in your muscles. That means the electrical activity in your brain is known as EEG, right? And the electrical activity that is going to happen in your muscles are known as EMG, right? If you are going to measure those things, or if you are going to measure the blood pressure, the pressure that means you are going to measure each and every parameter for your body, right? If you are doing that for your body, so it will, if you are using the instruments to measure the parameters of your body, then that particular field is known as biomedical instrumentation. Okay, so have you got the instrumentation and biomedical instrumentation? समझ में आया?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, okay. So this is about the instrumentation and biomedical instrumentation. Okay, so let us move into the basic medical instrumentation system. Okay, so the primary purpose that you need the biomedical instrumentation is to measure the presence of some physical quantities, right? You may have the many physical quantities. So the primary purpose of your biomedical instrumentation is to measure the physical quantity. And why you need to measure the physical quantity? For diagnosis or treatment, right? So whatever quantity you are going to measure in the body, okay, whether you are measuring the blood pressure, so you want to treat it or you want to do some diagnosis, right? So if for doing the diagnosis or for having some treatment, right? Diagnosis or treatment, what you are going to do, you have to measure that parameter, right? Like you have to measure the blood pressure, or if the doctor is thinking that there is some problem in his thought process, okay, if there is some problem in his thought process, so what the doctors do, he will suggest the EEG, right? So he will suggest the EEG. So why he suggesting the EEG? Because he want to diagnose the problem that you are having with your brain, right? With your brain, right? So the primary purpose of instrumentation is to measure or determine the presence of some quantity, right? And that quantity's presence will help the medical personnel to diagnose or treat it, right? So and what the other thing is, the majority of your instruments, whatever you are going to have, the majority, I'm not saying all the instruments. So majority of instruments that are available in biomedical instrumentation are measured in electrical or electronic systems, right? But there are some other systems like the ventilators, pyrometers, which also use some mechanical systems, right? So the biomedical instrumentation subject, you can say it as a combination of electrical, electronics, and mechanical. Okay, you can't say it that the complete instrumentation is a only because whatever you are going to measure the parameters, like if you are measuring some parameter, like if you, so there sometimes the mechanical system may also be useful for measuring that parameter, right? So but majority of it will be electronics and electrical, but there may be also sometimes you require the mechanical systems such as in ventilators or spirometers. I think you people know about the ventilators nowadays. During the COVID-19, you would to listen it about the ventilators, all these things. And coming on to the spirometer, okay, the spirometer is also used to measure the volume in your lungs. Okay, so how much capacity that your lungs have to intake the oxygen. Okay, so the for measuring the lungs capacity, so normally the lung capacity will be measured in liters. Okay, so for measuring the lung capacity, what we will use spirometer. Okay, so I am just covering these two here. Okay, so the primary purpose of medical instrumentation is to measure some physical quantities which will assist the medical personnel to treat or diagnosis, right? Because depending upon your EEG report or EMG report or depending upon your blood pressure, so whatever parameters that you are going to measure by using the instruments, this will be useful for the medical personnel, right? Then only he can effectively do that, do diagnosis or do the treatment, right? And majority of the instruments may have the electrical and electronic systems, but some of the systems may also need mechanical systems, like in ventilators and in spirometers. Okay, so have you understood still now?
Yes.
Yes, sir. Yes,
Okay,
sir.
so
Yes, sir.
ओके ओके इतना बार ऐसे कोई एक बोलो हो जाएगा, बहुत ठीक है, इतना बार मत बोलो. ओके, सो सो लेट अस सी द ब्लॉक डायग्राम. सो मैं आज के आपको यहाँ तक ही बताऊंगा, ठीक है, क्योंकि पहले दिन ही मैं ज्यादा क्लास बता दूंगा तो आप लोग सोच यू विल थिंक दैट सर फर्स्ट डे हैज टेकन टू मच क्लास like that. Okay, so today I'm just going to explain this block diagram. Okay, just I will explain till this block diagram and whatever the topics that you are remaining, the biomedical signals, I will just make you go to the PPT. Okay, so after that we are going to have the sources of biomedical signals, and then what are the regulations, and then what is the origin of bioelectrical signals, Okay, and then the fine. This is a very small PPT because this is an introduction PPT. So you have to go through all these topics. Okay. So today I will explain only up to this. Okay, I will explain the block diagram of medical instrumentation system. Okay. So uh, coming on to the block diagram. Okay. So if you have the block diagram here, so you can completely divide this block diagram into four different categories. Okay, the first one will be your measurand, the second one will be your sensor, the third one will be your signal conditioner, and the fourth one will be your display system. Okay, so if you want to divide your complete instrumentation, you can divide a complete biomedical instrumentation system into only four basic blocks: measurand, and then transducer, and then signal conditioner, and then display system. That's why I have written the headings also like this. Okay, display system. Okay, so let us see what the measurand will do. Okay, so what is the measurand here? So the measurand is the physical quantity. Okay, whatever the physical quantity, it may be your blood pressure, or it may be your uh, something the like EEG, or whatever the physical quantity that you are going to measure using the instrument. So that particular physical quantity is known as measurand. Okay, so the physical quantity that you are going to measure from the body, the physical quantity is known as measurand for you. Will be your measurand in the instrumentation system. Okay, so just remember this only. The physical quantity that you want to measure is your uh, measurand. Okay, so but what the next thing you need to know is, so the source, the major source for the measurand, because you are getting the signal here, right? You are, because for the complete system, what you are going to have next. Okay, for this complete system. Okay, so the measurand is an input source, right? So the input source for this complete medical instrumentation system will be your measurand. So so you, what happens means, you may get the measurements from the surface of the body, or you may sometimes need the measurement from the inside the body, right? So your measurement, that means the source. So normally the measurement will be your source, and it is not that always the measurement will be in one type. Okay, like the blood pressure, it will be in a pressure form, like, and like EMG, it will be electrical signal. Okay, and like that. Okay, and coming on to the volume of your lung, it will be how to measure the volume there. So the body will be your source for your instrument, right? Because you have to, the body is going to give the input for your complete medical instrumentation system. Okay, so so the body will generate different types of electrical signals. It may some different type of signals, not electrical signals. So it may generate electrical signal, or it may generate some quantity of mechanical signal, or it may separate different signals. Okay, so the measurement so, and that particular signal which you want to measure, the signal may you get it from the surface of the body, or sometimes you may have to go in depth into a tissue to measure that particular quantity. Okay, like let us take the example of EEG. Okay, so if you take the EEG. Okay, so if you take the EEG here, so if you take the example of EEG, so you can collect the EEG signal from the scalp. Okay, or you may also collect the EEG signal by inserting the pins into the head and directly making them touch on the brain of your brain, right? So in this way, you can get the measurement either from the surface of the body. Okay, like you may get the temperature, you can measure the temperature from surface of the body. You can measure the blood pressure from the surface of the body, because you are going to have a cuff, and that cuff is going to inflate, and it is going to see the particular vein. Okay, so so sometimes it will be easy for us, so that we can measure it directly from the surface of the body. Okay, but sometimes we may also have to go into in depth of the body for getting that particular signal. Okay, so we have to remember only this thing, that the measurement will be the physical quantity that the instrument measures. Okay, whatever the quantity that the instrument is going to measure, that will be a measurement, and this measurement will be from your body. So the body is a source for signals, and it can generate different types of signals. And then coming on to the measurement, you can get this measurement from the surface of the body, or it may be from deep chambers. Okay, so this is about the measurement. And the second block of your complete medical instrumentation is transducer. Okay, so coming on to the transducer or sensor. So I think you people know that what is the use of transducer. Okay, so what the transducers do? So the transducer will convert one physical quantity into other physical quantity, right? Or sensor will send the signals from there. Okay. So the transducer is the other important block that you are going to. I think you have understood the measurement. So measurement समझ में आ गया ना?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. तो अगर आपको कुछ प्रॉब्लम है, कहीं कुछ समझ में नहीं आ रहा तो मुझे बोले, मैं कुछ नहीं, मैं फ्रीली आपका सजेशन ले लूंगा, ठीक है? तो measurand will be the physical quantity, and then coming on to the transducer. So as I have said here, okay, as I have said here that the measurand may be electrical quantity and sometimes it may not be electrical quantity, it may be in other form, right? So there we need a particular block which can convert one form of signal into the required form. Normally what the in instruments we will do, we will convert other physical quantities into electrical quantity because it is easy for us to process or to make the noise filtration, all these things easy for the electrical signal, right? So whatever the parameter that you are getting, whatever your measurand will be, you have to convert this measurand into electrical signal, right? So that's the reason why we need the transducer here. Okay. So the purpose of the transducer here is the transducer here is it will convert one form of energy into other form. Okay. Or sometimes we use also sensor because the sensor is a device which will sense something from your body. Okay. Now you can consider this sensor as a detector. Okay. So the transducer will convert the signal into one form into electrical form, other form into electrical form, and sensor may sense the signal from that particular form, right? Like in LVDT, the it will be a combination of sensor and transducer, right? That means first the LVDT will measure the linear displacement, and then this linear displacement will be converted into electrical signal, right? So the first linear displacement will be your sensing part, and then you are having your transducer. So sometimes you need a sensor along with transducer, or sometimes you may okay. So that is the reason why I have written sensor and transducer here. The sensor will sense the signal physical parameter from there. Like here, the sensor will sense the physical parameter, and then this particular sensor physical parameter will be converted into electrical signal with the help of transducer. Okay. So this is the second important part of your biomedical instrumentation system. Okay. And coming on to the third important part. Okay. The third important block that you need to know in the biomedical instrumentation system is signal conditioner. Okay. So I think this is not here. The signal conditioner convert the output. Okay. So normally the transducer itself convert the signal into electrical form. Okay. So what the signal conditioner will do? So it will condition the signal. Okay. That means it may convert, like let us consider. I think you may have know about analog to digital converter, digital to analog converter, right? So the signal condition may also consist of analog to digital converter or digital to analog conversion. It may also perform the filtering. It may also remove the noise signals from that. Okay. Remember one thing: if you are designing any biomedical instrument, okay, if you are designing any instrument, okay, the first important thing you need to know is um, the noise should be very less in the biomedical signal, okay, because the noise will cause a major interaction to your signal, okay, like if you are taking some signal, because the frequency is an important parameter for us in the medical instrumentation, okay, like if you are taking the ECG, so you can get the ECG in between the frequency of 0 to 120 Hz, okay. So if in between this frequency, if a noise signal gets in between the frequency, so you may not get perfect output, you may not get perfect measurements from there. Okay. So the noise cancellation will be also done in the signal conditioner. So normally what happens in the signal conditioner, you will condition the signal. You may amplify it if you feel that my signal that I am getting from the transducer is having very less amplitude. Okay. So it is having very amplitude means like the mechanical you can know it as a voltage. Okay. So you may get that my signal that I am getting from the transducer is very less in amplitude. I need some improvement. Okay. So you can do that. We can improve the signal. Okay. You can improve the amplitude of the signal by using amplifier. Okay. So this particular amplifier will be the part of your signal conditioner. Okay. So this particular signal conditioner may have filter, it may have amplifier, or it may also have ADC, okay, analog to digital converter, okay, and then it may also have digital to analog converter. Okay, so the signal condition may perform all these things because its major purpose is to condition the signal so that it should be suitable for your displaying unit. Okay, because after the signal condition, what you will do, you will display that on your display, right? And the display may be different types. You may use a graph and pen to plot the curve. You may use a CRO tube. Okay, I will explain you in the display system. Okay, so this is the need of the signal conditioner is to condition the system. Okay, it may it may also perform sometimes the amplitude matching, impedance matching. Okay, so impedance matching may also be done by the signal conditioner. Okay, and then coming on to the next part of your this of your measuring instrument. So next part will be your display system. Okay, so what the display system will do, already the from the measurement the sensor has sensed the measurement, and then the transducer has convert the measurement into an electrical quantity, and then the signal has been conditioned by the signal conditioner. Okay, and then what we need, we need to display it, then only we can see it or we can record it, right? So the display system have major the major thing that the display system has to do is it has to record the signal or it have to display on a screen. Okay, so if you come on to the recording, so that you can use the conventional method of recording, like there will be a pen. Okay, there will be a one pen and a graph paper. So this pen may plot the curve like this. Okay, this pen may plot the curve. Okay, so the pen and paper system may be there, or you may also have the CRT tube. Like the CRT tube means, like you people have a TV, right? Like you may, if you see a old TV, okay, they are the CRT tube. They used to call it as a CRT. So you may also display the signal on a CRT tube, or you may use any computer or processor, and you can store this signal in a memory. Okay, so that you can retry the signal whenever you require. Okay, so the display system will have the major responsibility of displaying the system signal. Okay, so this is about the block diagram of your um, medical biomedical instrumentation system. Okay, so I will repeat once again. So the first thing is the measurement. Okay, you will see it from the block diagram. Okay, so this is our measurement. So the human subject from where you are going to collect the signal, those the subject will be your measurement. Okay, so this particular measurement, that means the human here will emit different types of electrical signal, different types of biomedical signals. So we need, so every time it is not guaranteed that we will get electrical quantity. Sometimes we may get some other type of signal. So we need to convert the signal into electrical form, right? So that's the reason why we are using sensor and transducers here. The sensor will sense the measurement, and then the transducer will convert this measurement into electrical or whatever whatever you need. Okay, and then you will come on to the signal conditioner. Okay, so in the signal conditioner, 1 minute. 1 minute, 1 minute. Okay, so the measurement will provide the signal for you, and then the transducer will convert the signal into electrical form, and then the signal condition in plays the other important role where it will amplify it and then give it to a signal processor. Okay, and the signal processor will process the signal, so it may eliminate the noise, all these things. Okay, and then 1 minute I have on the mic, right? So, and then after the signal conditioner, process the signal. Okay, whatever signal it is getting from the transducer, it will amplify and then process the signal, and then it will give it to the display system. Okay, so in the display system, you may use the alarms because if with the parameter that you are measuring will cross a threshold value, you make an alarm to get on, or you can display it on a display, or you can use a data storage system to store the data, or you can transmit this data using wireless technologies, or you can also record this data. Okay, so all these things will be done by the display system. Okay, so this is the basic block diagram of your medical instrumentation. Okay, try to remember this. Okay, so this may be very important for you. So I had explained it in a easy way so that you need to learn only four blocks, right? The first block will be your measurement, second block will be your transducer, third block will be your signal conditioner, and fourth block will be your display system. Okay, so this is your basic block diagram for your display system, okay, for your medical instrumentation. So normally try to know these two things. What is in vivo and in vitro? So you can see on the screen. So you can have to know that what is in vivo and in vitro. Okay. Okay. So in vivo means if you are measuring something, okay, on a within the living organism, okay, like if you want to measure the blood flow, okay, you want to measure the blood flow in arteries. So what you will do, you will use to insert the sensing element into the arteries. Then only you can measure the blood flow there. So if you're measuring some quantity inside the organism, that means you are opening the sensor and you are inserting the sensor into your body tissues, then that is known as in vivo. Okay, so still in vivo. Okay, that means in vivo you are made on or within the living organism. Okay, such as you are measuring the pressure in the chambers of heart. Okay, and coming on to the in vitro. So the in vitro measurement will be performed outside the body. Okay, like measuring the glucose level, or measuring the blood pressure, or measuring some other things. Okay, so you can know that what you will do in glucometer. So you will pinch on your finger and you will put the lead drop on a uh, stick, and you will just keep inside the blender, then you are going to see the glucose percentage that you are going to have in your body, right? So that will be in vitro, it will not be in vivo. Okay. So in vivo means inside your body tissue. In vitro means outside the body. Okay. So you, I think you may know or have understood what is in vivo and in vitro. Okay. So in vivo, try to remember that in vivo means inside the body. That means you are going to measure the parameters from inside the body. And in vitro means you are going to measure the, that means you are doing the measurement, you are performing the measurement outside the body. Okay. So this is okay. Because I don't want to make you bored, because पहले class में बोर करूंगा तो you may think that uh, so that's why I'm just making you the introduction. Okay, so I have introduced what is instrumentation, right, and then what is biomedical instrumentation. Okay, so instrumentation means measuring, you are using the instruments to measure some parameters which you need for monitoring and controlling. Okay. So coming on to the biomedical instrumentation, you are creating such an instrument which is used to measure, record, and transmit data to or from a body. Okay. So if you are using the creating an instrument to measure body parameters, then that particular field is known as biomedical instrument. Okay. So, and then coming on to the basic medical instrumentation, the purpose that we, why the biomedical instrumentation need is because if the medical personnel, okay, the doctor, if a doctor want to treat or give diagnosis to a particular disease, okay, so first he need to measure the physical quantity, right? Like if you are having any disease, the doctor will try to measure your blood WBC count. So if you measure some physical quantity in the body, so you may, the doctor may come into the conclusion that what the problem that the patient is going to have, right? So that's the reason why the medical instrumentation is a primary purpose for the doctor, because the doctor will can view the treatment or diagnosis more perfectly or more promptly when you know the quantity or when you measure the particular physical quantity. Okay, and then this okay, and then coming on to the basic block diagram. Okay, so whenever we are going to discuss about the basic block diagram of a medical instrumentation system, so the basic block diagram can be divided into four different categories. Okay, the first one will be your measurement, and then the second one will be your sensor and transducer, and the third one will be your signal conditioner, and the fourth one will be your display system, right? So measurement will be the source from where you are getting the signal for measurement. Okay, so and the source is is such a source that it will emit different types of electrical signal. This is different types of biomedical signals. Sorry, so this source will emit different types of biomedical signals. So these signals need to be converted from one form to other form. So that's the reason why the second important block here you are having in the instrumentation system is sensors and transducers. Okay, what this do? This will convert the signal from one form into the our required form. Okay, and then the other important part you are having here is the signal conditioner. Okay, so what the signal conditioners do here? This will condition the signal. That means first it will amplify it, and then it will send it to a signal processing system. And in the digital signal process, what it will do? It will process the signal. It will eliminate the noise, all these things, and then the final signal that you are having is a complete measured value. Okay, without noise. So this you have to display this value. Okay, so for displaying this value, we need a display system. Okay, so your display system may be a display or maybe a data storage system or maybe a recorder or sometimes it may be also an alarm, right? So because you can set a limit here and once that limit is crossed, your alarm will get turned on. Okay, so these are the different things you may have. Okay, so this is the bio block diagram of medical instrumentation system. Okay, and then coming on to the two different types of measurements. So the first one measurement that you are going to have is in vivo, and the other measurement that you are going to have is in vitro. Okay, what the in vivo means? If the measurement is performed inside the body. Okay, if you are performing the measurement inside the body, then that is known as in vivo. Okay, and if you are performing the measurement outside the body, then that particular measurement is known as in vitro. Okay, so in vivo and in vitro. The example for in vivo is like measuring the pressure in the chambers of the earth. So for measuring the pressure in the heart chambers, okay, heart, cell, ventricle, okay. So you need to go in, place the sensor at that chamber. Then only you may get the pressure of that particular heart chambers. Okay. And if you consider in vitro, okay. So in the in vitro, like if you want to measure the blood glucose level, so there is no need to remove the blood from your body and then take it in a test tube and you need to do something. You can also do that, like so blood, you can do like that, but there is also way, right? You can just place a blood drop and you can measure the blood glucose level or a blood pressure measurement. You will place a cuff on your limb and then you are going to inflate it and then you are going to get the systolic and diastolic pressure in your blood pressure meter, right? So this will be also a in vitro measurement. Okay, so just learn up to this today. So we will discuss the remaining things in the next class. Okay, so I will share the PPT with you once we complete all these topics in this particular presentation. Okay, then it will be also easy for you. Whenever I complete this presentation, I will share the PPT with you. Okay. So, do anyone having any doubts? If anyone having any doubts, you can ask the
No, sir.
doubts. यार, इतना ज्यादा समझ में आ गया क्या पहले दिन में?
Yes, sir.
So what is the
Yeah.
use of control system here?
हाँ?
What is the use of control system?
So normally what happens is sometimes you may also need the control like because actually we need to reduce the noise here, right? So
Yes, sir.
you what we use it to do means once the transducer converts the signal, okay, once the signal comes out from the transducer, okay, and you will compare the signal with a different signal, and if there is any errors, you will feedback the signal back to the controller. So that's the reason why you need a control system here, okay. So because we have to reduce the noise, so for reducing the noise here, okay. Sometimes you need a, I think in the control systems you are having PI, PID, PD controllers, I think, right? If you, I think if you have studied the control systems, you may have these PI, PD, and PID controllers. Okay, so sometimes
Yes, yes, sir.
we also know that these control systems are also used for having the noise cancellation. So there we need the feedback system so that we can get the more accurate output, we can reduce the noise. So there is a need for the control system there. Okay, for reducing the noise here. Okay, because as I said with you that the noise cancellation is one of the important thing that we have to do in a medical instrumentation because the accuracy, because in medical instruments the accuracy plays the major role because without the accuracy, if you design any medical device, then it will be not be useful for anyone. So for getting the accuracy, you need to reduce the noise. Okay, so for that we might also require sometimes a control system for reducing the noise here, error stabilities, all these things. Okay.
Okay, sir. Thank you.
Or anyone having any doubt? So what I will do means I am recording this recording of complete class also. Okay.